am Ji Soo-yoon. Today, I am honored to present our paper Palmrest Plus, Expanding Laptop Input Space with Shear Force on the Palmrest area. This work was done in collaboration with Hoyeon, Taejun, Sunbom, and Giyeok from HCI Lab in UIST. The laptops have been widely used for decades, and their standard design has remained unchanged, with the reliance on the touchpad and a keyboard for the user input. In the meantime, the Palmrest areas are typically in contact with the user's palm during the keyboard typing, and this offers a promising opportunity for supplementary input space. So in this work, we propose Palmrest Plus, an input space for seamless and rapid input on the laptop in the middle of the text entry. Users spend most of their time in a resting position while keyboard typing. However, users frequently break their palm resting state while interacting with the touchpad, and this occurs physical cost of switching between the keyboard and the touchpad. And previous studies have attempted to reduce this switching cost and enable intuitive command input. However, they still necessitate large movement of the hand or a natural hand posture. And other approaches require significant modification to the existing laptop design by augmenting sensors in every single key. In contrast, Palmrest Plus allows users to maintain the natural typing posture with less modification of the laptop design. So we were inspired by previous studies augmenting shear force input on the surface to expand the input space in a subtle way. Our approach also leverages shear force exerted by the palm on the palmrest area of the laptop. So we built a Palmrest Plus module, which is integrated in the palmrest area of the laptop. And this module includes a track point pointing stick that measures the two-dimensional shear force input exerted by the palm. So to use this shear force as an input, it is important to prevent false activation that may occur during the regular typing. Therefore, we determined the activation threshold of shear force input to distinguish intentional input from the normal resting behavior. And we first defined a push action as an application of shear force on the palm exceeding a predetermined force threshold without a slippage. And this push action can be made in 4 directions, including up, down, and left, right. Now we propose 2 interaction techniques of Palmrest Plus: Palmrest shortcut for rapid shortcut execution and Palmrest joystick for continuous value input. So first of all, Palmrest shortcut is an interaction technique for rapid command execution, and this can be used by performing the push action in one hand or in 2 hands or with a letter key press. For one-hand push, users need to perform the push action and release with one hand. And for 2-hand push, the users need to perform push action with both hands simultaneously before releasing the applied shear force. And lastly, for the 1-hand push plus letter, the user needs to perform the push action and then sequentially press the letter key before releasing. Palmrest shortcut may address the situation when a large amount of directionally related commands need to be mapped to the keyboard shortcuts. In such cases, keyboard shortcut requires using multiple modifier keys or less intuitive letter keys, making it very challenging to execute or memorize the shortcut. So we suggest mapping the 1-hand push shortcut and 2-hand push shortcut with the same direction to the commands related to directional movement, which frequently occurs during the typing. For example, 1-hand push can be used to move the cell in a spreadsheet application, and while 2-hand push with the same direction can be used to select the cells. And next, for the 2-hand push with opposite directions, we suggest semantically mapping the directional combinations to symmetrical commands. For example, pushing inwards and outwards horizontally can be mapped to commands like zooming in and zooming out. And for 1-hand push plus letter shortcut, it can intuitively expand the shortcut vocabulary. For each letter key, 4 directionally related commands can be mapped. For example, for F key, commands related to font size adjustment can be mapped. And for T key, commands related to tab manipulation, such as tab switching or tab opening, closing, can be mapped. So next, we propose another interaction technique called Palmrest joystick, which is used for continuous value adjustment. To use this interaction, there needs to be a distinct mode activation, which can be enabled by maintaining the push action in a certain direction. And once it is activated, the user can manipulate the continuous value with the right hand in a rate-controlled manner. And lastly, the manipulation will stop when the user releases the force with the left hand. So Palmrest joystick can be advantageous in scenarios requiring frequent switching between continuous value input and the typing, and particularly when precise value control is not required. So we suggest use cases for adjusting continuous values such as zooming or moving, or panning or resizing. And each function is triggered by the distinct activation mode, a method determined by the direction of the push with the left hand. To validate the interaction techniques, we conducted 2 user studies. Our goal was to verify whether the Palmrest techniques can reduce the switching cost compared to the conventional methods when frequent switching between text input and non-text input is required. So for the evaluation of Palmrest shortcut, we assess the performance of shortcut execution task in comparison to keyboard shortcut. So the task is designed to simulate a situation where a user executes the shortcut in the middle of the typing. Participants first type 6 letter keys in the central row of the keyboard and then execute the target shortcut. Lastly, they repeated typing the same 6 letter keys again. So we recruited 12 participants, and the experiments utilized a within subject design. We compared 3 types of Palmrest shortcuts with 3 types of keyboard shortcuts. We categorized the keyboard shortcuts based on the number of modifier keys used. And the results show that Palmrest shortcuts were significantly faster than keyboard shortcuts that use 2 or 3 modifier keys. But there was no significant difference with the keyboard shortcut with 1 modifier key. And all the Palmrest shortcuts showed lower hand displacement than the keyboard shortcut in the left hand, since the left hand moved to press the modifier keys in the keyboard shortcut. Additionally, we also looked at the gaze shift, and Palmrest shortcuts also showed lower gaze shifting toward the keyboard than the keyboard shortcut, particularly in the 1-hand and 2-hand push condition, which does not require any key press. In conclusion, Palmrest shortcut was reported to be comparable or even faster than the keyboard shortcuts, and the key factors contributing to this performance appear to be the reduced hand displacement and fewer gaze shift toward the keyboard. Next, for the evaluation of Palmrest joystick, we wanted to see whether it could reduce the switching cost compared to the touchpad when frequent switching between the text input and continuous value input is required, particularly when precise pointing is unnecessary. So we designed a task that combined the target acquisition task in the middle of the typing. So participants first typed 3 letter keys in the central row, and the cursor was activated by the push-up action with the left hand, and the selection was made when they release it. And the target acquisition task ended until the target was correctly selected. Lastly, the user repeated typing the 3 letter keys again. And the target includes both 1-dimensional and 2-dimensional conditions. For the evaluation, we recruited 12 participants, and the experiments utilized a within subject design with 2 independent variables, including the control method and the task types. And for the target condition, we used 2 width and 4 distance conditions. As a result, Palmrest joystick was slower than the touchpad for the target acquisition, but offers shorter switching time from and to the home typing position. In the 1-dimensional task, the Palmrest joystick was faster for most of the conditions. However, it became similar when the target distance became larger. In the 2-dimensional task, Palmrest joystick was faster than the touchpad only when the target width was large with the short distance. and otherwise it was lower than the touchpad. In addition, the hand displacement of Palmrest joystick was approximately 4 times lower than that of the touchpad, and this reduced hand movement led to the reduced switching time between the keyboard and the touchpad. In conclusion, Palmrest joystick is beneficial for large size and close distance target, especially for one-dimensional, and it reduced the switching time due to the reduced hand displacement. However, precise control with the palm is still challenging, especially for smaller targets and larger pointing movement in two-dimensional conditions. To summarize, we proposed Palmrest Plus as a supplementary laptop input space that leverages shear force input on the Palmrest area. We suggest 2 interaction techniques and verify the feasibility of the proposed concept through empirical user studies. But we are having a demo tonight, so if you're interested, please come and try out our prototype. Additionally, I am a prospective PhD applicant, so I'm actively looking for a PhD position for fall 2025. So I'm looking forward to meet potential future advisors or collaborators. So thank you for listening.
All right, questions? Thank you for the great talk. My name is Sohail Kianzad from Huawei Technologies. I'm wondering if you have faced any accidental activations in a normal typing situation. So did you run a test that people were actually trying to type like a page or something and see if there was any accidental interactions?
Actually, we conducted a user study to measure the exerted shear force during the regular typing, and we just applied that range to determine the activation threshold, but we actually did not evaluated the real performance, like during the typing, if it was activated or not. But we believe that we have defined the threshold as high enough to prevent the false activation. So yeah, thank you.
Hello, Sunjung Kim from Digis. So so usually force-based interaction is more fatiguous. So did you measure the user fatigue over the time when using the force?
Yes, we also measured the fatigue by the nasal TLX questionnaires, but actually there was not big difference between the touchpad and this Palmrest interaction techniques. Yeah, so there was not very interesting points that we noticed, but the users said, some users said, as they interact with the Palmrest techniques, their palms get sweaty, so it get a little bit harder to interact with it. So it depended by people, but some people thought it was a little bit, caused a little bit fatigue, but when they become familiar with the technique, they felt it was very uncomfortable to interact with, so yes.
Any other questions from the audience here? Okay. Thank you, Jisoo, again.